Hello, this is Rex King again. As I had stated in previous videos, I'm going to start working on the prototype so that we can improve this technology once and for all. This is going to be the first video that's going to be in a playlist of building the prototype. What I wanted to do on this slide is basically to show some of the main components that I'm going to be focusing on at first as I'm building this first phase of the prototype. The prototype, to build a complete machine, would basically be 3 copies of this part, 3 copies of this part right here, and the scissors would be 1, 2, 3, 4, 5 stacks of scissors and 3 tops. So it's a lot of parts, and I don't need to build a whole thing with all of those parts in order to prove it. The component that I need to build to prove it is basically what's here and behind me, but it'll have 2 stacks of scissors. I had to cut it off, but this basically twice, one right behind the other, and I'm going to leave it to where it actually be this bar can this linear motion connecting bar can be extended. So I'll make it with some bolt patterns at the end so that we can actually extend it to, because there'll be basically this component and then a mirror image of it facing this one. They'll be opposed to each other, working together. If you've watched the videos, you know. And then of course then there's the dead drop component too, which is another part. But to prove the technology, the lifting technology, all I need to do is just build this 1/3 of it. And so this is what I'm going to be focusing on at first and doing the testing. Because once we know for a fact that we can lift something up and release it, we know what the release value is, bringing it to the ground. We know what we can recover. More than anything, though, is if we can prove that we can lift something up and then retract from it and come down and pick up another piece that's substantially, small, like in a counterweight situation where there's a very, very little force required to do the lifting, then this mechanism in itself right here, nothing more is needed, but copies of this in lifting up masses up into a high structure where it can be, dropped on the other side by another mechanism. In other words, one way or another, this part right here being finished and tested thoroughly has much value, okay? And then it just basically says, when this proves itself, it's going to say, yes, now we've got these inventions. Let's see what else we can find, what else we can do. So anyway, with all that being said, let's just get right into it. Basically, these are just some of the main components. There's this, the moment arm itself up here, and the moment arm has actually a sliding mechanism on it. The way I've drawn this up is basically I'm imagining a motor back here with a lead screw and a sliding plate. And of course there'll be a dead load on it, and this will get this to operate as quickly as we can, such that it'll slide up and down this arm. And as it slides up this arm, of course the mass is magnified every foot out. This arm's probably going to be, I'm looking at on this model, it's going to be at least 6 foot long, 5 foot definitely at least, but I'm hoping to go 6 foot. I'm thinking like a 1.5 meters, so that we can get some really good projections of how this thing varies as it extends out, and the mechanical advantage that actually occurs, not just what you can calculate. Because that's what this is about, is proving the calculations. So this is the first 2 components up here. The next component really is the foundation, which it needs to be rigid. Well, yeah, I want to point out too, this has to be as rigid as possible when it's designed. So the sliding plate, of course, will work properly, and also the force will be transferred. We don't want to transfer, think of in terms of finite element analysis. In finite element analysis, any deflection is a movement in energy. So anytime you take this plate right here and bend it, instead of transferring the power, you're losing energy. So we want it to be as rigid as possible. So I'm going to be pointing out whether something should be rigid or flexible, and it's important that those are followed in this design. This arm needs to be as rigid. Of course, there'll be a roller surface here because this arm is going to roll on this bottom as this plate's up there. This thing isn't going to move that far. It's only going to move about this far. It's very short compared to the overall length. And then of course there's the foundation, which is rigid as well, a rigid foundation, because when this load is coming down and so forth, we don't want this to bend, because if it bends, then it's basically, instead of this transferring the power, it's just rotating the thing over. So it's important that this is rigid too and fixed. And of course there's the foundation, and the moment arm support arm is here. And this is a configuration itself, because we have to, when we want to set up the system initially, especially on the first few in this prototype, we need to configure it, do just different configurations to determine how, what's most efficient. So this arm will need to be flexible, rigid, but it'll need to be able to be adjusted up and down. And of course, on final designs, we'll know what the best settings are, and this will be a fixed arm. But it needs to be fixed and rigid, because again, we don't want it to rotate. The only rotation we want is the rotation at the point where it's supposed to rotate, where this is connected. Then there's the next part is this linear motion connecting arm. And this too, it's important that this is extremely rigid. There'll be, probably a couple of wheels back here. And of course, there's no connection between this. This is going to slide, past it if it needs to in the design. There won't be a connection between the two, because this needs to be able to move back and forth freely. And again, it's not going to really move that far. In proportion to this, it's going to be just moving a little bit. By the way, this isn't perfect to scale, as you can see, because these wheels would be the same size. All these wheels would be the same. This would be one height. So this would be fixed. The linear motion mode would be very rigid, because this is where the power transfer is being done. And there'll be several of these. There'll be at least 4 of these in the design, depending on how wide the design is. It might be 4 or 6 or something. We'll see how it works out. But definitely 4 of these arms. And of course, then there's the scissors arms themselves, which all of these are identical. And I've got a design for them, a specific design. They're not perfectly, shaped. There's a little configuration you have to do where they really work well and they don't have any conflict. And then of course there's the top platform. Of course, this wheel's going to roll on the bottom of the top platform, and this is really just half of it. Again, there's 2 scissors that would be on this one configuration, because it's not really stable unless there's 2 of them next to each other. Because the platform, when this wheel gets too close over here, it's just, it gets unstable. And of course, that could probably be fixed with some other things, but for this, just 2 of them. Anyway, I'm at 8 minutes. I just wanted to do a brief overview. Of course, it's not connected here, it's connected here. And so that this arm doesn't, because this is fixed here. So when this moves back and forth, the scissors goes up and down. And of course, this would be repeated. There'll be another wheel over here and another one like this over there. Anyway, what I'm going to do is I've actually used SolidWorks modeling. And so, in fact, I've got a lot of this stuff modeled already, as y'all saw from the other drawing, the patent drawings and so forth. That's all SolidWorks. And so, but that's not a final design. That was some modeling that I did in there. And so this design right here is going to be basically, I'm starting from scratch, but I'm using that software. And so anyway, over the next few weeks, as it's being built, I'm getting the components ready. I'll go ahead and reveal what I'm doing, and hopefully within a month or so it'll be finished, and we'll do some testing, and I'll put some videos up of the testing. Anyway, this is what my intent is to push now, is basically I'm using my ability to manipulate my world to make this happen. And hopefully it'll be something that'll be, from this work that I'm doing in my garage and so forth, like others in the past, it'll become something that's going to make the world a much more productive place. Thanks everyone for been watching and following along, and hopefully we'll all gain from this wonderful experience. Thank you.